Imagine, just for a moment, that you could jump back to any point in history or leap forward to witness the future. What would you do? In this video, we will explore the concept of time travel and all its intricacies. Are you ready to dive into the fascinating world of temporal manipulation? Let's get started. Time travel. It's a concept that has intrigued and fascinated us for centuries. It's a theme that has been woven into the fabric of our stories, our books, our movies, and has permeated our collective consciousness. Who hasn't, at some point, wished to travel back in time to correct a mistake, relive a cherished moment, or to leap ahead to glimpse what the future holds? From H.G. Wells' The Time Machine to the Back to the Future trilogy, from Doctor Who to Star Trek, time travel has been a staple of science fiction, a genre that often reflects our deepest desires and dreams. It has allowed us to explore the implications of our actions, the nature of cause and effect, and the ever-changing dance of choice and consequence. But it's not just the realm of fiction where time travel holds sway. It has also been a topic of serious scientific inquiry. Renowned physicists like Albert Einstein and Stephen Hawking have delved into this subject, exploring the realms of relativity and quantum physics, and pushing the boundaries of our understanding. Why are we so fascinated with time travel? Perhaps it's because time, in many ways, defines our existence. It's a constant, a steady drumbeat that accompanies every moment of our lives. We are born, we grow, we age, all in the relentless march of time. And yet, we can't touch it, can't hold it, can't stop it. It's intangible, elusive, always just out of reach. And so we dream of mastering it, of bending it to our will, of becoming, in essence, time travelers. We dream of visiting the past, of seeing the future, of stepping outside the steady flow of time and experiencing the universe from a whole new perspective. The concept of time travel has captivated our imaginations for centuries, but is it merely a dream, or could it become a reality? Before we dive into the mechanics of time travel, we need to grasp what time is. Picture this, if you will, a universe with three dimensions: height, width, and depth. We humans navigate through these dimensions daily. But there's a fourth dimension, often overlooked yet ever present, that's tied to the fabric of our universe. That dimension is time. Most of us perceive time as a constant, linear flow, marching forward without pause or deviation. Every tick of the clock, every flip of the calendar page propels us into the future while distancing us from the past. This unidirectional journey from birth to death is a common human experience of time. But what if time isn't as straightforward as it seems? Here's where the theories of time come into play. There are two main schools of thought: absolute time and relative time. The concept of absolute time is pretty much how we perceive time in our daily lives. It suggests that time flows at a constant rate, irrespective of where you are or how fast you're moving. This concept was widely accepted until a certain genius named Albert Einstein came along. Einstein introduced the theory of relativity, which gave birth to the concept of relative time. According to this, time isn't a constant entity, but a flexible one, influenced by speed and gravity. Imagine you're aboard a spaceship traveling close to the speed of light. According to the theory of relativity, time would pass slower for you than for someone stationary on Earth. Thus, a journey that feels like weeks to you could equate to years or even decades for your Earth-bound counterparts. This is known as time dilation, and it's been proven through various experiments. These theories challenge our linear perception of time and open the door to intriguing possibilities. If time can be slowed down or sped up, could it also be rewound or fast-forwarded? Could we, in theory, travel to the past or future? These are the questions that fuel the fascinating subject of time travel. But keep in mind, understanding time isn't just about contemplating time travel. Our perception of time shapes our reality and influences our actions. It determines how we plan our lives, how we remember our past, and how we envision our future. In essence, time is not just a ticking clock or a turning calendar. It's a dimension, as real and as integral to our universe as the space we live in. It's a river, sometimes swift, sometimes slow, altering its pace under the influence of gravity and speed. And it's a narrative, a story in which we're all characters, moving from one chapter to the next. The way we understand time forms the basis for how we might manipulate it. As we delve deeper into the mechanics of time travel, remember this: time as we know it is not just a backdrop against which our lives unfold. It's an active player, a key character in the grand scheme of our existence, and understanding it is the first step towards mastering it. Time travel isn't just science fiction. Some of the greatest minds have theorized its possibility. So let's buckle up and dive into the fascinating world of time travel theories. First on our list is Albert Einstein, one of the most brilliant minds in history. His theory of general relativity, published in 1915, transformed our understanding of space, time, and gravity. According to this theory, space isn't flat but curves around massive objects like planets and stars. This curvature creates what we experience as gravity. Now here's the exciting part. If space can be curved, then it can also be twisted and folded to create shortcuts known as wormholes. Imagine folding a piece of paper in half and poking a hole through it. That's a simplistic representation of a wormhole. So theoretically, if we could create or find a wormhole, we could use it to travel vast distances in space, or even back and forth in time. Next up is the intriguing concept of black holes. These cosmic phenomena are regions of space where gravity is so strong that nothing, not even light, can escape from them. According to Einstein's theory, the intense gravitational pull of a black hole can slow down time. This means that if you were able to hover near a black hole for a while and then return to Earth, you'd find that more time has passed on Earth than for you. This is known as time dilation, and while it doesn't allow us to travel back in time, it could potentially allow us to journey into the future. Now let's talk about the speed of light. Einstein's special relativity, published in 1905, states that nothing can travel faster than the speed of light, which is approximately 300,000 kilometers per second. But what if we could? Theoretically, if we could surpass this cosmic speed limit, we might be able to travel back in time. This is because, according to special relativity, time slows down as you approach the speed of light, and it theoretically stops if you could reach it. Moving on to another brilliant mind, let's discuss Stephen Hawking's take on time travel. Hawking suggested the concept of imaginary time. Unlike regular time that moves forward, imaginary time doesn't have a direction. It's a bit like a line that branches off from the timeline we're familiar with and moves in a different direction. In this realm of imaginary time, the past, present, and future coexist, which could potentially allow for time travel. However, it's important to note that these concepts are just theories. They've not been proven, and they're intensely debated in the scientific community. And even if they're possible, they present significant challenges. For instance, the energy required to create or sustain a wormhole or to travel at light speed is far beyond our current capabilities. Plus, the immense gravitational forces near a black hole would likely stretch anything that gets too close into a long, thin strand in a process not so lovingly referred to as spaghettification. As for Hawking's imaginary time, it's a purely theoretical concept rooted in the complex mathematics of quantum mechanics. It's not something we can physically experience or manipulate, at least not with our current understanding and technology. While these theories offer an interesting glimpse into the possibilities of time travel, they also present significant challenges. But who knows what the future holds? After all, science is a continually evolving field, and what seems impossible today might become a reality tomorrow. Time travel isn't without its potential problems. Ever heard of a paradox? It's a situation or statement that contradicts itself, yet might be true. When we talk about time travel, paradoxes are important. They present some fascinating and often mind-boggling problems. Let's start with one of the most famous time travel paradoxes, the grandfather paradox. Imagine, if you will, a time traveler who decides to go back in time and visit his grandfather when he was a young man. But here's the twist. The time traveler does something drastic. He interferes in a way that his grandfather never meets his grandmother. This means his parent, and subsequently he himself, will never be born. But if he were never born, how could he have traveled back in time to interfere with his grandfather's life? It's a mind-twisting loop, isn't it? Now, let's move on to another paradox, known as the bootstrap paradox, which is even more perplexing. It's named after the phrase, pulling yourself up by your bootstraps, which is considered an impossible task. The bootstrap paradox involves an object or piece of information that is sent back in time, becoming the very object or information that was later sent back in the first place. Consider this. A time traveler buys a rare book in the 21st century, then travels back to the 19th century and leaves the book with a young writer. That writer then uses the book as inspiration to write a novel, which becomes the very same rare book the time traveler will buy centuries later. The question here is, who authored the book? The book seems to exist in a loop, with no discernible point of creation. These paradoxes pose a serious challenge to the concept of time travel. They question the very nature of cause and effect and the linearity of time. If a time traveler can change the past, then the future from which they came could be altered or cease to exist altogether. This is known as the alteration of the past paradox. And what about free will? If time travel to the past is possible, it could imply that our actions are predetermined, as the past has already happened and therefore cannot be changed. This is a philosophical issue known as determinism. Furthermore, there's the time travel paradox of consistency. This suggests that any action a time traveler takes in the past must have been part of history all along. For instance, if a time traveler attempts to alter a historical event, they will inevitably fail, as the event has already occurred and is therefore fixed. This paradox suggests that time travelers are essentially bound by the constraints of history, unable to change anything. So as you can see, when it comes to time travel, it's not just a matter of hopping in a time machine and zooming off to the past or future. It's a complex concept, full of paradoxes and problems that challenge our understanding of reality. But don't let these paradoxes dampen your enthusiasm for time travel. Instead, think of them as intellectual challenges, puzzles for the mind. They invite us to dig deeper, to question our understanding of the universe and our place in it. These paradoxes present intriguing conundrums that any would-be time traveler would need to navigate. But who knows? Perhaps one day, we'll find a way to unravel these cosmic knots and truly master the art of time travel. Until then, we'll keep pondering, keep questioning, and keep exploring the fascinating world of time travel. While we haven't built a time machine yet, certain phenomena suggest time travel might be more than just a theory. Let's take a moment to appreciate the marvels of technology that give us a glimpse into the intriguing world of time travel. Global Positioning System, or GPS, as we know it, is one such example. You see, the GPS network relies on a constellation of satellites orbiting Earth, each one carrying a highly precise atomic clock. These clocks are synchronized with each other and with the clocks on the ground. But here's where Einstein's theory of relativity comes into play. According to Einstein, time moves slower the closer you are to a massive object due to the effect of gravity. This phenomenon is known as gravitational time dilation. The satellites in space are further away from the mass of the Earth than clocks on the ground, meaning they experience less gravitational pull. As a result, time ticks faster for them than for us here on the ground. Now, this difference is minuscule. We're talking about a discrepancy of mere nanoseconds. But even such an infinitesimal discrepancy could cause GPS systems to fail in their navigational duties. To ensure accuracy, the GPS systems are programmed to account for this time dilation effect. So every time you use your GPS to navigate, you're indirectly experiencing the effects of time travel. Moving on, let's delve into the realm of cosmic strings, theoretical cracks in the universe. These are not your everyday strings, but rather one-dimensional defects in the fabric of the universe, left over from the early cosmos. They're predicted to have extraordinary amounts of mass, enough to warp space-time around them. If these cosmic strings exist, and if they were to pass by each other, the space-time around them would bend, creating a loop of warped space-time. Now, if a brave traveler could create a spaceship fast enough to enter this loop, they could theoretically circle around it and emerge in their own past. Let's also talk about wormholes, a popular concept in science fiction. These are essentially shortcuts through space-time, connecting two distant points in the universe. If wormholes exist, and if they could be stabilized, they could potentially allow for time travel. However, it's important to note that we've yet to discover a real wormhole, and the concept remains purely theoretical at this point. Then there's the concept of time dilation due to speed, another Einstein gem. According to his special theory of relativity, time slows down for an object as it approaches the speed of light. This means that if you were to travel in a spaceship at near light speed, time would pass slower for you compared to someone stationary on Earth. So, in effect, you'd be time traveling into the future. However, achieving such speeds is currently beyond our technological capabilities. While these examples aren't quite the same as hopping in a time machine, they do suggest that time isn't as rigid as we might think. The concept of time travel, while still largely confined to the realms of theory and science fiction, has a few strands of reality woven into it. And who knows, with advances in technology and a deeper understanding of the universe, we might one day unlock the secrets of time itself. Until then, we'll continue to explore, theorize, and dream about the possibilities. So, what does the future hold for time travel? Diving into the realm of quantum physics, we find ongoing research that hints at the tantalizing possibility of time travel. Quantum physics, the study of the minuscule particles that make up our universe, has been challenging our understanding of reality for over a century. It's like the Wild West of science, where particles can be in two places at once, or even pop in and out of existence. One of the most promising areas of quantum research related to time travel involves quantum entanglement. This is a strange phenomenon where two particles become linked, and changes to one particle will instantly affect the other, no matter how far apart they are. Some scientists speculate that this could be a key to unlocking the secrets of time travel. For instance, imagine two entangled particles, one here on Earth and one on a spaceship traveling at nearly the speed of light. According to Einstein's theory of relativity, time would slow down for the spaceship relative to Earth. If we could somehow use the entangled particle on Earth to access the slowed time of the spaceship, we might be able to travel into the future. It's a fascinating concept, but it's still very much in the realm of speculation. The science isn't there yet, and many questions remain. How would we survive the journey? What about the energy requirements? And how would we return to our own time? While the practicalities of time travel are still far from being resolved, there's no denying that the theoretical groundwork is being laid. Thanks to the efforts of scientists around the world, we're beginning to understand more about the nature of time and space. And with each new discovery, we inch closer to the possibility of time travel. In the future, time travel may become a reality. We could see the past with our own eyes or explore what the future holds. We could witness historical events firsthand or even change the course of history. The possibilities are truly limitless. But it's important to remember that with great power comes great responsibility. If time travel were possible, it could have profound implications for our society. How would we regulate it? Who would have access to it? And what would we do about the potential for paradoxes and other time travel-related problems? The future of time travel is still very much in the air. It's a mystery that continues to captivate scientists and laypeople alike. But while we don't yet have the answers, the quest for understanding continues. And who knows? One day, we'll be able to step into a time machine and journey to the past or future. The future of time travel remains uncertain, but one thing is clear: our fascination with this concept is unlikely to wane. Time travel, once a concept relegated to science fiction, has found a place in serious scientific discussion. We've taken quite the journey today, diving deep into the vast ocean of time, exploring its many currents and whirlpools. Let's take a moment to revisit the highlights of our adventure, shall we? We started with a simple yet profound question: what if you could travel through time? This question led us to the understanding of time itself, a concept so integral to our existence, yet so elusive. We discussed how time is not merely a ticking clock, but a fourth dimension, intricately woven into the fabric of our universe. From there, we ventured into the various theories of time travel. We explored Einstein's theory of relativity, which suggests the possibility of time dilation and wormholes, and quantum mechanics, which proposes the existence of parallel universes. Each theory, while fascinating in its own right, also brings with it its own set of challenges and paradoxes. This brought us to the paradoxes and problems associated with time travel. The grandfather paradox, the bootstrap paradox, and countless others that challenge our understanding of causality and create mind-bending scenarios. These paradoxes serve as reminders of the complexity of time travel and the need for more research and understanding. We also looked at time travel in practice, or at least the attempts to achieve it. From using high-speed particles in particle accelerators to the theoretical construction of wormholes, we've seen that scientists are pushing the boundaries of our understanding in their quest to conquer time. Finally, we discussed the future of time travel, a topic filled with both anticipation and apprehension. Will we one day be able to navigate through time as easily as we navigate through space? Or is time travel destined to remain a concept of fiction and theoretical physics? Perhaps one day we'll unlock the secrets of time itself. Until then, we can only dream and wonder about the possibilities. But remember, every great journey begins with a single step, or in this case, a single tick of the clock. Subscribe to Time Pilgrimage for more fascinating content on science, technology, and beyond. Like, share, and comment below with your thoughts and questions on time travel. Let's dive into the unknown together.